Hi everyone. So this is our live stream. Let me see how many people are here. 6 people. Looks like there are about four missing right now. Um, I'll start the lecture in a minute, but let me start off by just kind of going over how we'll run the course. I think most people have figured it out by now, but just to be pretty clear, the Tuesday class, we won't actually meet virtually for the Tuesday class. For the Tuesday class, you'll have some videos to watch, and you're to watch them. And then for the Thursday class, that's this class right here, we'll have a live stream like this in which I'll go over problems that would have been part of the lecture. Now there are problems that I did in those lectures, but the problem with that is that you don't see me actually think them out the way you would in a classroom. You don't have the live stream there where you can chat a question in the text box. By the way, if people can hear me, can someone just say you can hear me in the text box there? Um, and there's also about a 30-second delay. You should realize that. So what we'll do is I'll lecture during the Thursday class like this, and you can ask questions, and it'll be a little bit more. It'll be less formal than the other lecture that you'll watch. The only exception to this will be the week of the test, and that'll be just live streams that week to prepare you for the test. Okay, so let me take a quick look at yeah, okay, people are saying they can hear me, and it looks like there's 7 people here. So this is a smaller class. There's only 10 people in the class. I guess 3 people are missing. Um, so, well, let's begin. What you should have seen up till now in terms of the videos is the video on the syllabus. Then there was a video on unit conversion. We'll be using MKS in the course. And then there was that introductory video to 1D kinematics. Okay. Now, the links, it's up on YouTube. The links for that are, in the emails, and I'll send those out. But if you lose the email, or you don't feel like scrolling through all your emails or whatever, they're all up on our Canvas site. Okay. So if you go through the Canvas site, you'll see them there. Now, they're a little bit on the Canvas site. They're a little bit ahead of what I've expected you to watch up to this point, but they're all there. Okay. And this live stream itself will go up on YouTube automatically, which is why I chose to do a live stream rather than a Zoom. With the Zoom, I mean, there are lots of other things I would have had to do. This tends to work out a lot better. So that's what we'll do. Okay. So well, let's begin. And if you have questions at any time, put them in the chat. Just realize that there's about a 30-second lag. I'll look at the chat every once in a while, and I might move on to another question. But if I see a question, I'll come back to it when I have a chance. Okay. All right. So the first thing was units. And this is pretty easy. Most of you have had some science course before, and you know that you have to use the right units. If you're using the wrong units, then or mixed units, then your answer comes out to be a mess. So in this course, we've chosen we're going to use MKS units, and MKS units are for length we're going to use meters, for time we're going to use seconds, and for mass we're going to use kilograms. Okay, and so the way you should do this is if you get a problem and the values in the problem are not in MKS units, you should convert them to MKS units. Okay, and I've got the first three questions that I have here are just some very simple conversions. Okay, so let's go through them. And again, if you have any questions, you just say, can you explain that or whatever in the chat, and I'll move on. I'll answer them when I can. Okay. All right. So let's take a look at question number 1 here. I say convert 100 kilometers per hour to MKS units. And this is very similar to the question that I had during the lecture. And I think it was 50 kilometers per hour there. 100 kilometers per hour, that's the speed limit in the highways. If anyone drives on the Canadian side of the border, on the highway like on the QEW, it's the speed limit is 100 kilometers per hour. That's roughly our 55 miles per hour. Okay, and the way to do this is you take a look here and you go, okay, so what units do I have in there? So you have kilometers, which is a length measurement. Okay, so remember there are 3 dimensions. There's length, there's time, and there's mass. Okay, length we're going to use meters, not kilometers. So the first thing you need to do is decide that you need to change the length unit here from kilometers to meters, but we also have a time unit. which is hours, and the MKS units for time are seconds. So we're going to need to convert the hours to seconds. So the way to do that is you start off by just getting an equivalency between the unit that you want to convert away from and the unit that you want to convert to. So for the kilometers, you've got 1 kilometer is equal to, and you do have to know a little bit of the metric prefixes. I won't overwhelm you with them. As the course goes on, you'll memorize these. There's not, I think you only need like 3 or 4 for this semester. But you know, kilometers, kilo is 1,000, so 1 kilometer is 1,000 meters. Okay, so there's our first equivalency, and we're going to use this to convert from away from kilometers and to meters. Okay, so the other one was time, and that was hours, and so we have 1 hour. And an hour is, of course, 60 minutes, and a minute is 60 seconds. So an hour is 60 times 60 seconds, and that turns out to be 3,600 seconds. Okay, so there's our second our conversion. All right. Now, what we're going to do with this is we're going to form fractions. So, you know, if the left-hand side and the right-hand side are equal to one another, I can always form a fraction where, you know, if I take 1 kilometer on top and I put 1,000 meters on the bottom here, this fraction has to equal 1 because the numerator and the denominator are equal to one another. So if you have like 3 divided by 3, that's equal to 1, or 7 divided by 7, that's equal to 1. So 1 kilometer, because it's equal to 1,000 meters, 1 kilometer divided by 1,000 meters is equal to 1. Well, you can make this fraction in 2 ways. You can make it either this way, or you can make its reciprocal, like this. So you could have the 1,000 meters on top and the 1 kilometer on the bottom. And you say, well, that's also 1, and which one will you use? Well, let's start answering the question, and you'll see. So over here, I have 100 kilometers per hour. We want to get rid of these kilometers, okay? So the kilometers are in the numerator, and so we want to put kilometers in the denominator so that when you divide out the kilometers, the kilometers in the numerator and the kilometers are in the denominator, they'll cancel out against one another. So you can always multiply by 1, and since both of these fractions are equal to 1, that's equal to that, and that's equal to 1, you can always multiply by 1. I'm just going to get rid of this 1, and I'm going to say, you know what, for 1, let me use this fraction right here. Now I had 2 there, and you say, why did I choose that one? So that the kilometers on top, that is in the numerator, will cancel the kilometers on the bottom in the denominator there, and the kilometers will go away, and you'll get meters. Okay, so this fraction will allow us to change our length unit to from kilometers to meters. The other one is the hours, and we're going to do the same thing. We're going to make a fraction here, so let me make the fraction right here. And I think it's pretty obvious here. Notice that the hours are in the denominator, so we're going to want the hours in the numerator. So the fractions have this form, okay? Something divided by something. We're going to want the hours in the numerator because they're in the denominator there. And 1 hour is going to equal 3,600 seconds, like that. And there we go. That's the fraction that we want there. So we're going to multiply that by, that, like that, okay? And if you do this on your calculator, well, yeah, before we do it on the calculator, let me just show you here what happens. See that kilometers there? That'll cancel against that, so let's get rid of those units. That'll cancel that. And the hours here, that'll cancel that, like that. And so all you're going to be left with is 100 times 1,000 meters multiplied by 1 over 3,600 seconds. You'll already see that the units that are coming out are meters per second. They're like that. And if you do that on your calculator, you'll get 27.77777 like that. Okay, meters per second. And let's round off to just 3 significant figures, so that'll be like that. Okay, so 27.8 meters per second. All right, so there's our first conversion. I hope that's pretty straightforward. And then, like I said, it's exactly like the one that I did during the lecture. All right. All right. I'll take a look at the chat here, see if there's any questions. None yet. All right. Let me go on to the next one. So here we have convert 7,500 cubic centimeters to MKS units. Now this is actually a volume problem, and we're not going to be using volumes during the first semester. We will have other units where you're going to have the units squared or the units cubed, but volumes are a part of next semester, but since we're talking about unit conversion in general, this is the time to look at it, okay? So I can't on my whiteboard here, it's just a text editor. I can't really do like the superscript cubed. And so what I'm going to do is I'm just going to do this like caret here. And so this centimeters caret 3, that means centimeters cubed. And whenever you have like a length times a width times a height, that's a volume. All right, so centimeters, they measure length. Okay, they're a length unit. But we want to convert to MKS. And centimeters are not the MKS units for length, meters are. And so the first thing we need to do is say, okay, well, how do you convert between centimeters and meters? And the way I do this is I always like to think of the bigger unit. The meter is bigger than a centimeter. So I'll take 1 meter, one of the bigger unit, and I'll say, well, how many of the smaller units are in the bigger unit? And the answer is 100 centimeters. Yeah, 100 centimeters, like that. Okay, so 1 meter is 100 centimeters. And so this is another one of these metric prefixes, and you just have to remember that centi means a hundredth, and so 1 centimeter is a hundredth of a meter, or 1 meter is 100 centimeters. By the way, you can make the fraction the other way around too. Here I had the bigger unit in terms of the smaller units. I could also go 1 centimeter is equal to 0.01 meters, and it would work out just fine. It's just that, I mean, I kind of like this a little bit better. It's a little bit clearer, but this equivalency is exactly the same as that. All you have to do is divide both sides of this one by 100 and you'll get the other one. Okay, so they're both totally equivalent to one another. So we want to make this fraction, and we want to put, it's pretty obvious, we want to put the centimeters in the denominator and the meters in the numerator. And so you do this, you say, okay, we want the centimeters in the denominator. Okay, so we'll take the centimeters here, and we'll put that in the denominator there like that. And we want the meters in the numerator like that. Okay, and you think you're done, but you're actually not. And the reason is that this is centimeters cubed. So there's actually 3 centimeters there multiplied by one another. So you've got like a length measured in centimeters, a width measured in centimeters, and a height measured in centimeters. So there's actually 3 centimeters there. And you know that, like, if you have 3 cubed, you can write that as 3 times 3 times 3. Or if you have 5 cubed, it's like 5 times 5 times 5. So centimeters cubed, that's really like centimeters times centimeters times centimeters, like that. So you just have, you actually have 3 centimeters there. But over here, you just have 1. So this centimeter will cancel one of them, but then you've got 2 others to go. And you say, well, what do you do with that? Well, you know what? You just do this again. You just take that and multiply it by another one and multiply it by another one. So now this centimeter here will cancel against the first one. The second centimeter will cancel against the second one. And the third centimeter will cancel against the third one. The 3 centimeters will go away and you'll get a meter, and a meter, and your answer will come out in meters cubed. Okay, so here, let me show you that on another line. Okay, so let me just copy this entire line again. All right, like that. And see that first centimeter? That one is going to cancel against that one. Whoop, sorry. It's going to cancel against that one. Okay, the second centimeter, it'll cancel against this one. And the third centimeter here will cancel against the third one there, like that. Okay, and so now you have 7,500. Multiply by 1 divided by 100, multiply by 1 divided by 100, multiply by 1 divided by 100. And I think that's like divided by 1,000. Let me just do it very quickly on my calculator. You can't see my calculator, but that's what I'm doing right now. 5, 6. And yeah, it's 1,000,000. Copy, paste, and we have a meter, and then we have another meter. Whoops. And we have another meter, and 3 meters, that's meters cubed. Okay, and so that's how you convert units when you have more than one. Okay, so in this semester we're going to see a lot of second squareds. Okay, and so when you have to convert, second squareds to second squareds, you're going to have 2 of them, and so you might have to multiply by the conversion factor twice. Next semester we're going to have a lot of volume units, and so there you'll have like things like this, and so it comes up quite a bit. So that's how you do it. You don't just multiply by your conversion fraction once, you multiply it once for every one of the centimeters that you have there. Okay, let me take a look at the chat. And I don't see any questions, so it looks like you're okay with this. Okay, So let me go on to the next one. This is the third one. All right. So the third one here, we're not going to work with pounds and inches very much, but I wanted to show you something because, you might say, well, geez, I don't remember centimeters, or I don't remember millimeters, or I don't remember kilometers. There's only going to be a few metric prefixes that we'll have in this semester. But if you don't remember, let me show you how you can quickly look them up. You can look them up using Google. So let me just quickly switch to my, where is it here? There it is. Okay. Oh, sorry, that's my dog barking at the mailman. Um, the dangers of doing things live. Okay, so what you're seeing here right now is I just switched to my browser, and you should see there Google. And all I did in the Google bar is I said convert from LBS, which is just pounds. You could have even written the word pounds in there. Convert from pounds to kilograms. Okay, and it'll come up. And you could do this with anything. You could do it with currency, U.S. dollars to Canadian dollars. You could do it from inches to meters. You can do it from ounces to milliliters. I mean, any kind of conversion that you want. And we won't need all of those, but in real life you might, or in some other class you might. And I don't know if you know about this, but Google will just bring up these conversion calculators for you. Okay, and so you just say convert the first unit to the second unit, and there it is. It says 1 pound is equal to 0.453592 kilograms. Okay, so we need that number, and let me get that, copy and paste it into our whiteboard here. And I'll switch back in just a second. Let me just copy and paste this in here first, like that. And let me switch back now. Oh, wrong one. There we go. Okay, so there we are. And so all I did here, you can see I wrote 1 pound is equal to 0.453592 kilograms. Okay, so there's our conversion between the one unit and the other unit, and the rest of it is you proceed the same. So you start off by saying, okay, I have 13 pounds here like this. Okay, and I want to multiply by my conversion fraction like this. And so you say, well, what do I want in the numerator? What do I want in the denominator? Well, the pounds here are in the numerator, so we want the pounds in the denominator like that. Okay, and of course the other part of the fraction goes into the numerator like this, like that. And you multiply that out, and let me do that quickly on my calculator. It's kind of trivial, but since we're doing it, we might as well finish it off. Multiply by 0.453592 equals, and it turns out to be this number here. And paste, and there we are in kilograms. Okay, so the answer is 13 pounds is the same as 5.8967 kilograms. Okay, too many significant figures, but that's okay. This is not that important. All right, so I just wanted to show you this. Even though we're not going to use pounds and inches, I just wanted to show you this because I wanted to show you that this method generalizes for like any units. And in some other classes you may need to do these kinds of conversions. So they're there. Okay, let me look at the chat again, see if there's any questions. All right, no one seems to be asking me any questions, and so I think that's good enough right now for the conversion. Let's go on with the kinematics. Okay, so before I jump into this problem, let me actually remind you a little bit of kinematics, and actually remind you or tell you why it's important to really show up for these live streams. Okay, if you miss a live stream, you can always watch it because it is being recorded, but it's kind of important to show up for these live streams because in the lectures that you watch for Tuesday, I give you the polished problem. It's completed, and especially when we do physics problems where there are diagrams, okay, you don't see the steps that I took in drawing those diagrams. Okay, I mean, I kind of say it out loud, but it's really important that you actually watch me do it, and watch me do it in real time, and ask questions as I do it. So not so important right now, but when we get to that point, I'm going to bring out my other whiteboard, and you'll watch and you'll see how I'll draw one part of the diagram, then I'll draw another portion and another portion, and you can see me work that out. That's going to be really important for throughout the course, but especially for the kinematics where there's going to be a lot of diagrams. Okay, so what is kinematics? If you're looking at a car and it's driving down the road, or you guys are probably you're probably ESS majors. You're looking at the human body, and you see the human body move in a certain way. You can ask lots of questions about that motion. Like one thing that you can ask is like, why is what caused the person to move that way? Okay, or if you're watching a car, the car is moving and then it slows down and stops, you can ask what caused the car to slow down. Well, those are one set of questions, and questions about what causes things, they're usually called dynamics in physics, and we'll study them later in the course. But before we even get there, we might just want to say, like, can you describe this motion? Okay, and can you describe it mathematically? This way you can be very precise about it. All right, and so that's what kinematics is about, and that's what that the lecture was that you saw in 1D kinematics, that introduction. All right, and the quantities that are really of interest in kinematics are um, uh, the position, like where are you at various times, the velocity, that's how fast you're going, and the acceleration. And the acceleration is how fast you're speeding up or slowing down, because you might be moving, but you might be speeding up as you move, or you might be slowing down as you move. Okay, you look at a car going down the road and it's going at a constant 30 miles an hour or 50 kilometers an hour. It's not speeding up, it's not slowing down. It has a velocity of 50 kilometers an hour, but it has an acceleration of 0 because it's not speeding up or slowing down, and acceleration is a measure of how much it's speeding up or slowing down. But if the car hits the brakes and it goes from 50 kilometers an hour down to 0, well, then there was an acceleration. Okay. Now, the other thing about that lecture was I had to distinguish between average velocity and instantaneous velocity. And in this lecture, or in this example here, we're not going to touch the instantaneous velocity. The instantaneous velocity is like how fast something is going at an instant in time. Okay, and it's actually the average velocity, but where you take the time interval over which the average is measured and you make that time interval smaller and smaller and smaller and smaller and smaller, okay, until it shrinks down to just like a point in time. All right, now mathematically you can do that, but you need calculus to do that, and this is not a calculus based course. So you could just think of the instantaneous velocity as an average velocity but measured over a very, very short time interval. So here I said, we have a car and it's moving down the road, and at time t equals 0, that is if you have like a stopwatch and you look at the time on the stopwatch says 0 seconds. At 0 seconds, this car is 2.5 meters from some reference point. And that reference point is like in the lecture I gave you, was like a tree. But you could choose any reference point you like as long as you're consistent. And, you call that the origin, and you're going to measure everything with respect to the origin. So, you're looking at the car, and your stopwatch says 0 seconds. And the position that the car is, you measure it along the road, it's 2.5 meters. And then you wait a little bit, and at 1 second, you say, where is the car? And you measure it from the same reference point, and you find that the car is at 3.1 meters. Okay, and then at 2 seconds, the car is at 3.9 meters from that reference point, and then at 3 seconds, it's at 4.9 meters. Okay, so this is an experiment. In fact, you're going to do this very experiment in the lab, but not with a car. You're going to use a linear air track. And a linear air track is basically a straight track, but it's if you look at it on an edge, it's kind of triangular, and there's a glider that sits on top. And the the track has these holes, and that squirts out air and shoots out air, and it causes the glider to hover above the track so that it moves up and down the track without velocity. And along the side of the track, there's a ruler, and so you can measure where is the car. Where's the glider in this case? Where's the glider at various times? And there's a point on the air track that you're going to take as the origin, and that'll be it. So you're going to be doing this exact same thing in the lab. Now, again, this is an average because you can't get instantaneous velocities out of this kind of information. Like if I asked you, how fast is it going at 0.5 seconds? You don't know. It's just that information is there because you didn't measure it. Or you could say, how fast is it going at 0.1 seconds? Or how fast is it going at 2.3 seconds? You don't know. All right. Not only that, but you just don't have the information to do the average over anything smaller than a 1 second interval, because from 0 to 1 seconds, that's a delta delta t of 1 second. So there's a time interval of 1. 1 to 2 seconds is another time interval of 1, and so on. Okay, and so the gradation here is just 1 second leaps, and so you can't possibly calculate the velocity in anything less than a 1 second time interval. And for instantaneous, you want to shrink it right down to like as close to zero as possible, and so 1 second is too big. And so really this whole question is about average velocities. When we get to 1D kinematics under the assumption of constant acceleration, basically falling. When things fall, they fall at a constant acceleration. Okay? When we do that, then the instantaneous velocity will be a lot clearer. Okay, so I'm going to do this problem, but before I do, let me just take another look in the chat. And it looks like you don't have any questions. Okay, so well, let me start. Let me do it. Okay, so question A is what is the average velocity during the time interval from 0 seconds to 1 second? Okay, and the way you do that is what do you mean by a velocity? All right, so a velocity is how far did you travel, and that is our delta x. Okay, that's how far you traveled, divided by the time it takes to travel that, and we'll call that delta t. Okay, and I apologize, I can't do the triangular deltas. Again, this text editor doesn't allow for that, but there it is. Okay, so delta x is how far did you travel, and delta t is the time that it took you to travel it. And delta t, because this is an average, delta t can be big. Okay, it can be some, in this case, 1 second. But if you're talking about your average velocity when you're going to Niagara Falls, New York, that might be even 30 minutes. Okay, so that delta t could be as big as you like. All right, and normally for the average we put a little bar on top of the v, but I can't do that again in this editor. All right, so there's the formula, and let's do it. So what do we do? Okay, so delta x, what you do for delta, like when you say how far did you travel, well, that's where you are at 1 second minus where you started from. So it's like your final, which is that where you are at 1 second, minus where you were at the 0 second mark. So at 1 second, you're at 3.1 meters. Okay, so that's going to be our final position, minus, and at 0 seconds, you're at 2.5 meters, and so we'll subtract 2.5 meters. All right, and there's your final minus your initial, and that's your delta x. That's how far you traveled in that time interval. Okay, now on the bottom you've got delta t, and delta t is the same thing. Think about your stopwatch. Think about your final time that you read off of the stopwatch, your initial time that you read off of the stopwatch. So the final time was 1 second. Okay, the initial time was 0 seconds, and so your time interval is 1 minus 0 seconds, like that. Okay. So let's do it. In the numerator here, we have 3.1 minus 2.5, which is 0.6. Okay. In the denominator, we have 1 minus 0, which is 1. So 0.6 divided by 1 is 0.6. And the units are meters divided by seconds. And there you go. And meters per second are the units for velocity. Okay. Now, that's not the velocity all through the trip. That was the average velocity just during that first 1 second time interval, like that. Okay. All right. So let me see. Any questions? No. Looks good. All right. Let's do it again for the time interval from 1 second to 2 second. Okay. So same formula. There it is, like that. And we're going to do our delta x. So delta x, that's the change in the position. It's how far you traveled is your change in position. You do the final position, that is the position at 2 seconds. And you look in your chart here, at 2 seconds you were at 3.9 meters. Okay, so there's our final position, minus the initial position, that was the position at 1 second. So you look in the chart here, at 1 second I was at 3.1 meters, like this. All right, and then divide that by your delta time, and the delta time was your final time. That's like imagine you're watching your stopwatch and you say it ended at 2 seconds. Okay, that's your final time. And the interval began at the 1 second mark. So there's the 1 second, like that. And of course, 2 minus 1 is 1 second. So this time interval was also 1 second long. And this is going to be 0.8. That's 3.9 minus 3.1 is 0.8 divided by 1. So it's 0.8 meters per second, like that. That's like that. Okay. All right. So notice that during the first second of the trip, you were traveling at 0.6 meters per second, but during the second of the trip, you actually sped up a bit. You're at 0.8 meters per second. And let's see what happened during the next second. So the next second was between the 2-second and the 3-second mark. Okay. So again, when I say second interval, that second interval begins at the 2 seconds. So you're looking at your stopwatch and you see it's reading 2 seconds, and then tick, 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 and then it reads 3 seconds. That time interval between 2 and 3 seconds, that's this time interval in there. And we want to know what was the average velocity during that time. Okay, so same formula. The average velocity is the change in position divided by the change in time. So the final time is 3 seconds. Where were you at 3 seconds? 4.9 meters from your reference point. Okay, minus where were you at 2 seconds? At 2 seconds you were at 3.9 meters from your reference point, like that. Okay, divided by the time interval. And now your final time is 3 seconds. Read off of your stopwatch. Your initial time was 2 seconds. Again, it's a 1 second interval, but there it is. And so what's this? This is 1.0 meters per second. Okay. So during that third second, you are actually traveling at 1 meter per second. So take a look at what's going on here. You start off at 0.6, you speed up to 0.8, and then finally you're traveling at 1.0 meters per second. So every second you're speeding up a little bit, okay? If you look at this and you think to yourself, all right, the velocity is changing over time. What does that mean? It means that there's an acceleration, okay? Now, I'm not going to ask you to calculate the average acceleration, but let's just think about it. We could probably figure out what it is. If you're going from 0.6 to 0.8, that's an increase of 0.2 meters per second in 1 second. So that's 0.2 meters per second, or 0.2 meters per second squared. That's what the average acceleration would be between the first and second time interval. And by the way, if you're going from 0.8 to 1, that's another increase of 0.2. That's an increase of 0.2 meters per second in 1 second. So that's an increase of 0.2 meters per second squared. That's your acceleration, okay? So I didn't ask you to do this here. Calculating an average of acceleration on top of an average velocity is kind of messy. It's not that important. So, during a test or something, I won't go past an average velocity, okay? So there it is, all right? Let me see if there's any questions. No, it's looking good. All right. So let's do the last one. And I say, what's the average velocity during the entire trip? So the entire trip is from starting at the 0 second mark and going up to the 3 second mark. So it's a 3 second trip. And you might say, well, how fast was I going during the entire time? Notice this is it's not the instantaneous velocity at any point in this motion. It's actually like a really gross measurement. It's a measurement over the entire trip. Okay, and so it's the same formula, but now our delta t is going to be from 0 to 3 seconds. Okay, and so here's our formula, like that, and that's going to equal delta x. So delta x is where did we start? Where did we end up at 3 seconds? Well, we ended up at 4.9 meters, like that. Okay, so there's our final. All right. Minus, what's our initial? That was at 0 seconds, so our initial was at 0 seconds was 2.5 meters, like that. Okay, and divided by, now it's not a 1 second interval, it's actually a 3 second interval, because we ended up at 3 seconds. We started at the 0 second mark, and so you can see here that our delta t is actually going to turn out to be 3 seconds. And if you work this out on your calculator, I remember the answer because I just did it for the other class. It turns out to be 0.8 meters per second, like that, okay? And, when you get an answer, let's see if it makes sense. 0.8. Well, the slowest you were going during this time interval, during the entire trip, the slowest you were going was during the first time interval, the first 1 second interval, and you were traveling at 0.6 meters per second. And then you sped up to 1 meter per second. So in the middle is the 0.8, and that's in fact what you got. Okay, so This is the average over the entire trip, like that. All right. So that's it really for this class. I mean, I don't have enough stuff for us to go over, and so I really don't want to do more of these problems. They're pretty straightforward. If you have any questions, I can answer them. I just want to tell you one more thing before we end, and that is over the weekend I'm going to produce a small little assignment online. It'll show up in Canvas as a quiz because that's what what Canvas calls them. It's multiple choice, and there'll be some questions like this. There'll probably be 3 or 4 questions like this. Okay, and you'll have a week to do it. I'll email you the link on Monday. You go in there at your leisure and do the assignment, and then I'll probably take it down on Friday. I do need to take it down because I may have to go over it, and it's not fair if I go over it, like especially during a live stream. Some people might say, I don't understand how you did this question. So I might actually go over the very questions that I have you guys do. So I have to take them down, but you have a whole week, and there's only going to be about 4 of them. And it's mostly to make sure that one, you've been keeping up and you're understanding the material, but also the questions on these assignments are going to be very similar to the questions that you'll have on the tests. Okay, so let's see, anything in the chat here? There is a 30-second delay, so I got to wait a little bit, but I'm not seeing anything. Is everyone good then? Waiting a little bit here. Any questions? Let me know, guys. Oh, I've got one. Will this be every week? Yeah. So just to explain, Timothy, Tuesday we don't meet like this. I'll email you a link for a video to watch, and then on Thursdays we'll have this. The only exception will be to this will be during the weeks when we have the tests, and then we'll probably have more live streams. I'm not sure right now, but we'll definitely turn the Tuesday class into a live stream. But I'm getting the all goods in the chat, so feel free to leave the stream. I think we're done here. Okay. Oh, wait, one more question. Sorry. As far as the questions that are posted to Canvas, yes. What about them, Timothy? I don't quite understand your question. It was incomplete. As far as the questions that are posted to the Canvas. Oh, I'm sorry. Now I understand. It took me a second. I should read that in the context of the previous. Yeah, every week I'll give you an assignment. Yeah, 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 yeah. Those will be. You'll have one every week. You'll have one every week. They'll take. I'm gonna guess they'll take you about half an hour to do to an hour. I mean, it depends how like if you know your stuff cold, you can do them in probably 10 minutes. Okay, but if you have to go back and think about them, then they might take a little bit longer. Okay, but yeah, we're gonna have them every week. All right. Yeah, sorry, Timothy, I didn't quite understand your question, but we're good. Okay, is everyone done then? Don't forget, if you have any more questions, you can always jump on that uh, the Google Hangouts in the evening, or email me, whatever. All right, bye bye.